Hello everyone, this is John from the Gear Masters, and today I'm going to do a simple line following program for the robot. This is very good because this particular program only uses one sensor, and it's very simple. And in addition, following a line is a very good way to reach the beacons in the autonomous, because that way, what we have in our robot is we have it go forward until it sees a line, and then once it sees the line it turns a little bit and starts following it, and then it'll follow it until it actually sees the color of the beacon. And when it can sense the beacon's orientation, if like blue is on the red or the left side, then it'll set an arm that can swivel back and forth to be a position for either the right button or the left button, and then it'll charge forward and actually press the button after that. So it sounds pretty complicated and it looks complicated, but it's actually pretty simple. It just has a lot of steps. So to do this, we're going to be modifying our old program video example. You can see that in lesson 1, and if you didn't see it, basically all you need is a left motor and a right motor, and that's all we're going to be doing for this experiment. What we did, we had a button and we had it follow the line continuously until you press the button. You can do that, but actually I'm going to show you a simpler way, just making it so it can stop. So to do this, first we're going to need to go to the blocks, and actually we're going to need to get a new op mode. This is going to be a continuous op mode, and I'm going to rename it. Let me zoom in actually. I'm gonna name it line follower, and then I'm gonna name it the same thing. Excuse my spelling. And this is going to be an autonomous program. So what we need first off is we need a light sensor, and those are called the FTC optical distance sensors because they're actually made for sensing distance, but they're basically the same. They're the same as the NXT light sensor. So I'm gonna rename this one light, and I'm gonna name it light here. And I always name them the same, or mostly the same, just because this is the part that you put into your configuration file, and this is the part that you program with, and it's just easier if they're both the same for our team. You don't necessarily have to do it that way, but I find it's easier that way. So we're gonna start with we're actually gonna need to make another one. This one is going to be, oops, not what I meant to do. This one is going to be a non-autonomous op mode named light tester, and this program will actually let you be able to sense the values of the colors, and I don't want the start, and this is good because you can calibrate your program for your specific conditions. I know that if you move the sensor up or down a little bit, you probably want to recalibrate it, and actually to do this we have our sensor hooked up to one of the Lego Tetrix pieces, because that way if we need to move it down about a half a centimeter or up half a centimeter at a time, we can actually pull out the little thing, slide it up, and put it in, and it's much easier than using screws and brackets, and it's not going to be holding any weight, so really Lego is just a lot easier. So to do this, we're going to go to the light tester area, and we're going to have it in a loop. So when the loop goes, it will it will enable the LED, and what this does is it has a light that shines down so it can tell the color. If you were going to use the optical distance sensor to try to find a to try to determine the beacon, we tried to do that and it was very hard. You had to have the tolerances like exactly perfect, so we ended up we're just going to use a color sensor. But if you were going to use that, you would have this enabled to false, but since we're going to not be looking at the light that comes at us, but we're going to be making our own light, we want it to be true. And so then we are going to telemetry some data, so we're going to go to FTC Robot Controller 1, and then we are going to go to telemetry add numeric data. The key is going to be, here it is, light level. And the number is going to be from the light sensor light detected. So in the light sensor, there's multiple things you can do. You can do the light detected or the raw light detected. I don't really recommend using the raw light detected, because then if you want to actually convert it from lux to a number that is you're able to use, you have to design your own equations, and with the light detected it already has it, so it's just a very simple output. And so this will telemetry the data of the light detected. And so what I recommend you do now is you load this up on your phone, and you have to of course register the light sensor in the configuration file. But what I recommend you do now is you run this program and you look at the numbers that it gives you for when you're holding the light sensor over black and when you're holding it over the color, or black is the color of the mats, and when you're holding it over the white because the lines are white. And I recommend you don't just like grab it in your hand and hold it. I recommend you actually mount it on your robot and place your robot so that the light sensor is over either the mat or the white tape. And so then you're gonna need to remember those values. And what I did with ours, I found a value. Ours was, I think it was 0.08 for the dark gray mats, and then for the white we had something like 1.2. And so, or yeah, I think it was 1.2. And so I just took the middle of that as the value of what we're gonna need to do. So to do this, we're gonna have to create some variables. So I'm gonna do it in global variables. You don't have to, but it's just a lot easier. And so this is gonna be called the threshold, and we're gonna start with that set to 0. All of these you can set, this one you can set